Okay, welcome back students. So I hope the voice is clear this time. There was some voice issue in my previous class. Okay, so I hope that has been rectified. I just rechecked everything. So students, today we are going to talk about some searching techniques, and in this particular class we are going to talk about the linear search. So what exactly is a linear search? The searching that is done in a linear fashion is called as linear search. So the method that is used to search an item into an array. So I'm using the word array out here because we are going to make use of a list which will be having the items, that is the homogeneous items, which means the data types of all the elements of the list will be the same. So we are going to have a simple list, and the list will be having numbers, and then we are going to make use of the linear search technique, and we are going to search for a number in that particular list. So already maybe we have done this program before, but now this is the part of the syllabus, so we are going to take this, and there are a few more things that we need to learn about, we need to do with the linear search. So the simple thing is, suppose if I have a list, so I will just define a list, and I have some numbers in this particular list, and I'm making this list as a sorted list. Okay, so it does not matter that much, but the things that we're going to learn, we're going to have a sorted list. So let me have, this is how many items, this is 1 2 3 4 5 6 7 8, and I'll have 400 and 500. So this is a sorted list, and now for searching for a number in a list, we can make use of the algorithm, that is the linear list algorithm, and the searching technique is quite simple. So I can do this using a simple for loop. So I can simply say, and for example the number to search is item is equal to maybe 90. Okay, so number to search is 90, and we need to search this number in a list, in this given list. So how we are going to search for this number? So what we are going to do is we are going to make use of the list traverser. List traverser means we are going to compare this particular number with every element or with every number present in the list. That's the approach. And when we say that we're going to compare with every number, we are going to start with the index value, that is 0. So we are going to start with the index value 0, that is the first element or the first item in the list, and then we are going to compare this number with every number that is present in the list in a linear fashion. So that is the linear approach we are keeping it, and so it is called as the linear search. And the moment this number gets compared with any of the number, we are going to just return the position of that particular number. Okay, so that is what we need to do. So simply I can use for I in range, and I can give the, that is len and of l, right, and I can give a colon, and then I can simply say if l of I, if it is equal to item, if it gets equal to any of the index value gets equal to the number that is the item, then what I need to do is straight away I can return the position from here itself. So obviously I have to put this into a function. So this is a linear search, that's the name that I'm going to give, and I'm going to pass the list and the item. So let me just fix up the indentation, and now this is okay, all the indentation is perfect. And okay, if it gets compared, then I'm going to straight away return that position that is present in the list, okay, the index position. And then I'm going to give a else part to this for loop, right? So this else part will get executed, it will get executed if this particular for loop will go for all the iterations. So if this condition never gets satisfied, so it is going to complete all its iteration. And if it completes all its iteration, then the else part is going to get executed. So which means that if this goes for all these iterations, this condition never got true, which means I'm going to return something like false. So which means the number is not present in the list. And then comes the main program. Just remove this. Okay, then comes the main program, and list is, this is the list. Let me just shift it over here, it will not make any difference. And this is the main program that I'll be starting from here. So this is the list, a global list, and then I will give a call to the function, and I will say position is equal to, and then the call to the function, that is a linear search, and then the list and the item. Okay, just for the information that we have learned about the stacks and queues in the previous class, and that's not over, children. We are going to make use of stack. Now I'm going to teach you how you're going to make use of a stack for performing some of the operations that the operating system does, or the language processors does for us. Okay, so we are going to come up with that. So back to the topic. So this is a linear search, then I give a call, then I have passed the list and the item, and then I can simply say if position, if it is equal to, that is false, so I can simply print the message that the number is not present. So this is the perfect way to do it, and this. And then comes the else part, else, which means the number is present at position comma, let me give a colon out here, okay, a colon, and then the value, that is position. So obviously if this goes false, which means this position has some value and it is going to display that value. So this is one of the approach, or one of the way to do the coding. It says invalid syntax because I've given colon out here. So now it's okay. So let us just run this program and check the output. So I'll give some name like linear search .py, and name position is not defined, and that is because over here, so over here I need to return what? I need to return, that is I, if I'm not wrong. So I'm going to return I out here. So let us run this, and it says that the number, that's the output, the number is present at position 4. So it is present at number 4. So it says, okay, this is 1 2 3 4 and 5, that's the fifth position. But since we are starting from 0, so it is saying 4. So simply I can give this as +1, and that will solve my problem. So let us run one more time, and now you can see that the number is present at position 5. So this is the program, this is the algorithm for the linear search technique. Now the same program we can do, I'll just copy this, I've saved this anyway, and now I'll copy the entire thing, go to a new file. That was the one way of doing it, and the same way we can do it with the help of a while loop. And the while loop is because while loop is something that matches the algorithm of the linear search. So there is a standard algorithm that the linear search has, and if you do it with the while loop, so it will be very much matched with the standard algorithm that we have for the linear search. So let us do the same thing with the help of a while loop. So I'm going to do I is equal to 0. It almost all same, only the loop is the while loop. And one thing that I can do is standard way of doing it is if I is less than and the len of L, that's the first thing, and then over here only I can apply the next condition with the AND. So I'm going to join this condition, so both the conditions should be true, and it says that the L of I, if it is not equal to the item, and this is the standard way of doing it. And I'm simply going to increment, that is I is equal to I plus 1, and then outside the while loop what you need to check is if I is less than len of L. If it is still less than the length or the size of the list, which means that um, in that case, which means that this particular while loop has gone for, or it hasn't gone for all the iterations. That is what it means. Okay, if this is less than the len of L, which means this condition went false somewhere and the I did not reach till the end of the list. This is what it means. And then I'm going to simply say return I, else what else, and what will be the else part will mean is I is actually equal to the len of L, which means that I has reached till the end of the list. And if it has reached end of the list, which means it has not found the number, so I'm going to return false out here. So this is the algorithm, and this is a standard algorithm for searching the number in a linear search. Okay, so two ways I've shown you. And let us just run this program now, and this I will say as a linear search, and linear search 2.py, and it says the number is present at position 4, the same thing that we have out here. So I'm going to give this as +1, and now if I run this particular program, we're going to have the number is present at position 4. So these are the two ways, children, that I have shown you how we are going to do it. Okay, so I'm going to keep it short for today. This is the technique of linear search, and tomorrow we are going to implement one more complex algorithm, not really complex, a bit complex, and how to insert a number into a linear search, and which is in sorted order. So for example, if this is a linear search, I mean a sorted number, and using you know so how we are going to actually add a number which into this particular list, and it should be in sorted order. Okay, so for example, if the number is something like maybe 80, 80, 80, so this is 1 2 3 4, so this is 78, and then the 80 should come at the place of 90, and all these numbers, that is 90, 100, 102, 105, all these numbers should be shifted one position towards the right. So we are going to shift all these numbers to the position right, and then we are going to make an empty space and going to enter the new number. So how to insert a number, okay, in a sorted list is what we are going to learn tomorrow. This is not really that complex, but yes, a certain complexity is that if you really go through it properly, then it becomes pretty easy. So this is the linear search, and then we are going to do the insertion of the item into the linear list, that is in a sorted order. And then we are going to learn a very important technique, that is the binary search. So this is a linear search, and the problem with the linear search is that it takes a lot of you know iterations. So obviously if the number is at the last, so it is going to start from the first position and go to the last position. So we have to go on checking, we have to go on comparing with every number, and that is the problem that this particular algorithm has. We have a better solution for this, and the solution that we have is the binary search. Even that we are going to learn in the upcoming class. So tomorrow we are going to learn about how to insert a number into a sorted list in a sorted order. Okay, so that's it for today, children. I'm going to give both the programs to you. So let me just copy this before I say bye to you. I will just do the things for you. I'll go to Word, and this is the first linear search program that we implemented using the for loop. I will copy this to the Word and convert that into a PDF. Let me do it for you. Okay. So that's the program, and I will save this program. That is the folder that we have is my folder, that is class 12. So that is linear underscore search. That's the first program, and let me just convert this into the PDF. I'm going to give this program to you. Please everybody implement this program. Do not waste time. As soon as the class gets over, implement the program and check the program if there is any errors. Obviously this is a very simple program, so if there are any errors, it will be very minor errors, very simple errors that you can get rid of. So that's the first program that I did it for you. Then I'm going to go for a new file, and please implement both the programs that I'm giving it to you. So that's the second program that we have, and paste this, and let me go to export, and this is a linear search 2, and I haven't saved this file, so I'll just save this file as well. So both the programs, children, I'm giving it to you. Maybe for few people it is pretty simple, but not for everybody. So please everybody implement this, because during the exam, and even if it's easy, you feel it's easy, still you implement this, because during the exam it becomes, you make it confused with a lot of things. So it is always to keep on practicing even if you know it, and that's the way to make yourself perfect. Okay, so let me just save this. That is linear search and 2. So I'm sending these files to you, children. Please implement it. Bye for now.